Hi, pre-algebra students. Today we're going to get into chapter 11 and we're getting into the numerical side of things. We're done dealing with statistics and now we're going to talk about square roots, okay? Put your thinking cap back on, and a while ago we dealt with squaring numbers. And remember, squaring a number simply means taking that number and we're multiplying it by itself. So 9 squared means 9 times 9, which is 81. It doesn't mean 9 times 2. It means 9 times 9. Okay, now squaring can be undone. Remember when we talk about undoing operations, when we deal with equations, the opposite of multiplication is division. That is how we undo multiplication, is we divide. Well, we can do the same thing when we deal with squaring a number. To undo squaring a number, we take the square root. And the square root is simply taking a number and going backwards with it in a sense. So up here, 9 squared was 9 times 9, and we said it was 81. When I take the square root of 81, I want to know what number is multiplied by itself to get 81. So we're going backwards, and we know that 9 times 9 is 81, so the square root of 81 is 9. So we just undid our square, basically. Okay, so square roots undo a square. You've got to remember that. Okay, here's the thing. We're going to actually talk about imaginary numbers. That really truly is a thing that does exist in math. I'm not making it up. Square roots, we can see square root of a negative number. Okay, the real thing about this, I shouldn't use the term real because we're dealing with imaginary, but taking a square root of a negative number results in an imaginary number, and we abbreviated I, okay? That imaginary number is not in the real number system, okay? And you will deal with that once you get up into algebra. But right now, all we need to realize is when I take the square root of a negative number, it is not a real number. It's an imaginary number. So let's take a look here. Let's see how we can do with it. If I take the square root of 25, what's my answer? Is it a real number or is it an imaginary number? Well, it's positive and it's a perfect square. It's 25. So the square root of 25 is 5. It's real. Take a look at number 2 here. What is the square root of negative 4? Remember, here we have our negative. So that's not real, and we're simply just going to write not real. If you notice here, I just pulled down the answer for for number 3. I have negative square root of 64. Now, because that negative is not inside the radicand sign, I can go ahead and take the square root of 64, which I know a square root of 64 is 8. That negative sign gets attached in front because it is not located inside. Okay, so take a look at number 4 here. What's the answer of 36? Square root of 36 is the number that we multiply by itself to get 36, and that would be 6. Here, is that real or is it imaginary? Well, this is real because the negative is outside, so I need to know what number multiplied by itself gets 100, and we know 10 times 10 is 100. So I'm going to take the square root of 100, which is 10, and then I have to attach that negative in front of it. So my answer is negative 10. This one here. Okay, right away we notice the negative sign's out here. Sure, we can go ahead and do that, okay? But look inside. I've got another negative sign. This, because that negative sign is inside, that is not real. Okay, so let's keep going here. A few minutes ago, I used the term perfect square. And remember, a perfect square is an integer that is the square of another integer. Okay, so basically that means I'm working up my integer chart. Think of the one that's hanging in my classroom. Integers are 1, 2, 3, 4, 5. And then we have the opposite, the negatives for it. So a perfect square is simply going 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, okay? And so perfect squares are taking the square roots of that integer, okay? And so the square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. So taking the square root of a perfect square gives me an integer. That's all a perfect square is. Square root of 25 is 5. The square root of 36 is 6. So these are all perfect squares. Okay, but if you notice, there's a lot of square roots in between 4 and 9. What happens to those? Well, those are what we call our irrational numbers, okay? Irrational numbers, remember, are numbers like pi and decimals that do not end. Taking a square root of a number that is not a perfect square results in a number, a decimal, that continues on and on and on. When you put it into our calculator, it looks like it ends because it rounded that last number up. But truly, taking the square root of a not perfect square results in a decimal that continues on, a non-terminating. And so it is an irrational number. Okay, so our book then asks us, okay, since it's not a perfect square, can I estimate it? And yeah, you can estimate it. And we're going to estimate it by looking at what positive integers that are perfect squares lie on both sides of that number. So look at step number 1 here. We're going to look at the square root of 32. Well, we know 32 is not a perfect square. So I need to estimate what this is. So I'm going to think what perfect squares lie on either side of 32. So I know 5 times 5 is 25, and I know 6 times 6 is 36. So 32 lies between both of them. So then what I'm going to go ahead and do is take the square roots of those perfect squares. Okay, so then once I take the square root of it, step 3, the square root of 25 is 5, the square root of 36 is 6. So I know the estimation that the square root of 32 is between 5 and 6. That's estimating it pretty good. Okay, so let's go ahead and practice this, okay? So here, they want me to estimate the negative square root of 18. Well, if you notice that negative, remember, is not inside, so I can go ahead and work with that. So I need to first go ahead and work with this. What perfect square lies on before 18 and what perfect square lies after 18? Well, thinking about it, I know 4 times 4 is 16 and 5 times 5 is 25. So those are the perfect squares on either side of them. So because of that negative in front, I'm going to attach that, if you notice, in front of these square roots. Now, following through to step 3, I need to go ahead and take the square root of each of them. And so the square root of 25 is 5. There's my negative attached in front. Take the square root of 16, which is 4, and there's my negative. So I know the negative square root of 18 lies between negative 5 and negative 4. Okay, let's go ahead and do example 2 here quick. Okay, what perfect square lies on both sides of 69 here? Well, I know 8 times 8 is 64. Well, that's definitely less than that. So I've got the square root of 64. I know there's my 9. And what perfect square lies on the other? If 8 times 8 is 64, 9 times 9 is 81. So I'm going to take the square root of both of them. And now take the square root of the perfect 4, and I get 8. Square root of 69, and I get 9. So I can estimate that the square root of 69 lies between 8 and 9. Okay, now sometimes we want to estimate it and get it a little bit closer here. Okay, so we can actually estimate it to the nearest tenth. In reality-wise, in real life, all we're going to do is take the square root of it. okay? But we can get a good estimate working with this step that we're going to talk about next. But if you need to be very precise, just use your calculator, use the square root button. Just to remember, it's been a while since we've been in class. To take the square root on most of your calculators, you're going to hit your second button and then hit the x squared button. That gives you a square root. And then go ahead and put in 48, and you'll notice that you get 6.92, and really that decimal continues on. It does not end. It does not terminate, because the 48 is not a perfect square. Okay, so let's say if I want to estimate it, I'm going to go ahead and I'm going to estimate the square root of 7 to the nearest tenth. What's the next thing I need to do? Well, we're going to go ahead and we're going to do just like we did. Find the perfect squares that are on either side of 7 here. And I know square root of 4 and the square root of 9 are both perfect squares. I'm going to go ahead and think this through here. So I know I get 2 and 3, okay? Now, square root of 7, does it lie closer to the 4 or does it lie closer to the 9? Well, what's half of this in between? Well, think this through. If I've got square root of 4, square root of 5, square root of 6, square root of 7, square root of 8, square root of 9, where does 7 lie closer to? Does it lie closer to the 4 or does it lie closer to the 9? Well, it lies closer to the 9, just by a little bit. Okay? Now, what is half of 9? Half of 9, I'll do it that way, half of 9 is 4.5. Okay? And 4.5 is going to be right about in here. Okay? So the square root of 7 just lies to the right of the halfway point. Okay? Now, to make a good estimate of it, and that, we're going to go ahead and remember when I took the square root of it, I got 2 and 3. Okay? So I know that once I take the square root of 7 is going to lie, remember, just to the right of the halfway point, which would be 2.5 here, once we take the square root of it. And so I'm going to say it's about 2.6. You could also say 2.7. You'd be really close. Okay? So let's actually put it in our calculator and see where it falls. Okay? So the square root, so I'm going to take that, of 7 gives me 2.645. Okay, so 2.6 was a really good estimate. 2.7 was really close because if that was one more number, you would have wanted to round that up. So when we're estimating, if you put 2.6 or 2.7, I would give you that as credit for it. Okay, so let's go ahead and practice this one more time here. Let's look at problem number 1 here for my example. Okay, I'm going to go ahead and I'm going to find the perfect square that are on either side of this. So 4 times 4 is 16, so that's pretty close. And the other one would be 5 times 5 is 25. Okay, looking at this, okay, where does this 23 lie closer? Does it lie closer to 25 or does it lie closer to the 16? It's definitely closer to the 25. Okay, because really there's only the square root of 24 in between that. So that's going to help us determine, once I take the square root of 4 and I get 5, I know this is really close to the 25. So I'm going to estimate that it's about 4.8. Okay, if it was like the square root of 24, I would have probably put it about 4.9. Okay, so we're going to use this, think this through, how far away? Some kids like to actually write each of these square roots out so they can see it better. And 19, 20, but that really takes a long time to do. Okay, so think it through. Where does your square root lie compared to your perfect squares? Number 2 here is we do it the same thing, except we would attach that negative outside. So what perfect square is around 11? Well, we'd have the square root of 9 and we'd have the square root of 16. Which one is this closer to? Well, I only have the square root of 10 in between here. So once I take the square roots, 4, I know the square root of 11 has to be between 3 and 4. And because it's really close to the square root of 9, I'm going to say it's about 3.2 for my estimation. Now don't forget, I've got that negative sign in front. So I need to attach that negative in front. Okay, now let's keep working on because there's a lot in this section here. In this section here, it talks about working with our radicals. Now we can work with arithmetic operations. If you notice here, I've got 3 different examples. I've got the square root of 64, adding it to a square root of 5. I can go ahead and do that. I'm going to first go ahead and find the square roots of each of these, because it's not underneath one symbol. If you notice over here in this example, I've got the numbers underneath one square root. So that means I have to go ahead and do the math first before I can work with the square root. Okay, so let's go ahead and work with this one. Take the perfect square. There, square root of 64 is 8. There's my plus sign. The square root of 25 is 5. All I'm going to then do is add them together. 8 plus 5 is 13. Here, remember I said this was underneath one square root sign, so I need to go ahead and do my math between this. 72 minus 23 gives me 49. I like this because I know the square root of 49 is 7. 7 is going to be my answer, so I needed to first combine the numbers underneath, which was a good thing because these weren't perfect squares. So once I did my math, it was nice. I got a perfect square and then I could take the square root. Over here is a little bit more complicated. They added some things. Now remember in algebra, if we've got things side by side without a symbol in between, that means multiplication. So this truly means -4 times that square root. But we're going to save that for last. We're going to go ahead and combine the stuff underneath the sign. So I'm going to go ahead and take 116, subtract 35, and hopefully I get a perfect square, which I do, and it's 81. Now I'm going to go ahead and take the square root of 81 first. I'm not going to deal with this until the very end, remember? So I'm going to continue on and leave my -4 over here. And the square root of 81 is 9. Now, I just put this in parentheses to remind myself this is multiplication, so I don't forget to do it because they're side by side. And so now I deal with multiplication. -4 times 9 is 36. I've got one negative, so it's -36. Okay, guys, let's see how you do with these examples. We're getting a little bit more complicated here, but you guys are pros at this. Now, what's the very first thing I need to do here? Are these underneath one square root sign? No, I'm going to go ahead and take the square roots of each of them first. So the square root of 64 is 8. There's my subtraction sign. Square root of 25 is 5. And now I just subtract them and I get 3. This one over here, they're starting to look a little bit more scary. Relax, take it step by step. So remember, we have division here, or if you want to think of it as a fraction. We've got to first simplify our numerator and denominators before we can do any kind of division here. So we've got all this underneath one sign here. So let's go ahead and do some multiplying here because I have to get that into one number. So 9 times 16 gives me 144. And we're going to go ahead and do the math underneath this one. And I've got 81 minus 45, and I get 36. I'm relieved because I right away noticed these are perfect squares. So now I'm going to go ahead and continue to get this down to numbers here. What is the square root of 144? Well, that's 12. There's my division sign again. What is the square root of 36? That would be 6. Now I can go ahead and simplify this and go, what is 12 divided by 6? And my answer is 2. Okay, so it's not too bad once you take it step by step. Okay, let's do one more here. The next one is we're going to treat it the same thing. So here's my division sign. We need to work with my numerator and denominator separately. This is a perfect square. That negative sign is outside, so I can still work with it. So I'm just going to set that negative sign aside and take the square root of 144, which is 12. Okay, now let's go ahead and work with what's inside my parentheses here. Okay, if you notice, these are not under one sign, so I can go ahead and treat these separately. What is the square root of 25? Square root of 25 is 5, and the square root of 9 is 3. Okay, now inside my parentheses, what is 5 minus 3? 5 minus 3 is 2, and that's what that simplifies down to. So I have my negative 12 up on top. 2 times 2 is 4. And now I can do one more last step to simplify. What is negative 12 divided by 4? And I get a negative 3. Okay, so we're going to go ahead, take things step by step. Okay, don't psych yourself out when you start seeing multiple things together. Do your order of operations and follow it through. If you got any questions, go ahead and email me or text message me. Good luck, guys. Take it slow and do it step by step.